Hi, and welcome back to our channel. Let's start with an overview of Android Lifecycle before getting into the specifics. The Android Lifecycle dedicates the various steps that an activity goes through from development to termination. We can manage app state, handle configuration changes, and maintain a pleasant user experience by understanding the lifecycle. Now let's explore the key lifecycle method that allow us to respond to the lifecycle events. The life cycle starts with on create when the activity is first created or recreated after being destroyed. The first method on start is called when the activity is about to become visible, followed by on resume, which is triggered when the activity is becoming visible and is moved to the foreground. From on resume, the on pause is called when the activity comes, a different activity comes to the foreground, which puts the current activity to the background. From on pause, the on resume is triggered back if the previous activity comes back to the foreground, which will move back to the on resume state, followed by on stop, which is triggered from on pause, which gives us an opportunity to release the resource that is not required while the activity is in a stop state. Number six is when the activity is being destroyed, the on destroy is will be called. This is where we will actually release all the resource and close the activity. Followed by number seven, on restart is when we call from previous activity is closed and launching the current activity to the foreground. So the on create will be called back when the current activity is being killed by via higher memory and you have to navigate back to the parent activity. Next, let's look into demo Android lifecycle. I have created a simple application to show the concept of the lifecycle demo. Let's launch the application. So in activity A, we have prepared two new buttons. The first button is to move to activity B, and for the second button, when you press on the close activity, it will close the current activity A. A similar thing have been done on activity B. When you press on the first button, it will navigate back to activity A. When you press on the second button, it will close the activity B. This is to demonstrate the Android lifecycle and also the behavior when we launch the new activity. If you do need to understand further on how to create the XML layout and design it, please refer to the previous introduction to Android Studio video. The link is provided in the description below. So now let's go back to the main activity. So let's go back to the main activity. One of the quick ways we could always troubleshoot or try to figure out what's going on in the code is by adding a log, whichever method that we want to check and print out the value it needed. In here, I created a tag called activity A and add the log I have added on create, on start, on resume, on pause, on stop, and on destroy, and so on. Similarly, I have also added the same log in activity B. As I have explained, when we actually click on the button, we will either launch an activity A or close the current activity. Similar to activity B, when we press on the button, we will move back to activity A or close the current activity B. The coding was done in a simple method to ease the understanding. Next, let's run this application in the emulator from the command prompt. If you do want to know how to run from command prompt, please watch the previous video, Introduction to Android Studio. I've shown how to actually run it from the command prompt for you. once once the emulator has been launched, we click on the play for the installation to begin. So after the installation, the application will be launched. When it is launched, the first thing it will be showing is the activity A. So now let's look at the logcat filter. The onCreate is created to initialize the activity, followed by onStart, and followed by onResume when the activity is becoming visible to the foreground. From activity A, when we click on to move to activity B, we could see that the on pause actually is being triggered from the log. This is because we actually put the activity B into the background. So when activity B becomes a foreground, which means that it puts the activity A to the background, so it will trigger on create, followed by on start, and on resume when the activity comes to the foreground again. We could see that current activity A on stop lifecycle is actually triggered due to its in background, and we actually stop listening to the first activity A. Next, let's try to close the current activity B. When we close on the activity B, it will move back to current activity A. So from the logs, we can actually look when moving to activity A, the activity B actually moved to on pause, and in activity A, the on restart was actually triggered back from the life cycle. From activity B, we proceed that because we call the finish when we calling the first activity, and this will actually trigger the on stop and on destroy, where it will release all the resource it was holding for the activity B. Next, when the activity A becomes to the foreground, we will trigger the on restart, followed by on start, and on and resume will be triggered again. Now, let's say we press on close for activity A. It will trigger on pause, followed by on stop, and finally on destroy to release all the activity resources. So there's two main key points that we always have to remember. First, we always have to release the resource or listener that the activity is holding. For example, in here we could see that during close activity, we could always release the resource from on destroy or on stop when we're actually closing the activity. Second is the second most important point is we could avoid running on the main thread, which could takes up a lot of processing and rendering when the UI is being created. For example, here we could take a look when we call activity B and we call on finish, we actually running on the UI thread. The reason why we actually do it is to reduce the UI slowness, or worst case, the screen is stuck. Try to use a runnable execute to run on a secondary thread, which could reduce the slowness of the UI. Next, we will be looking into handling configuration changes. Let's look into handling configuration changes. One common challenge in Android development is handling configuration changes such as device rotation and also changing day and night mode. So whenever we are trying to change rotations or we're trying to do a day and night mode kind of configuration change, this will actually change the app state. So to maintain the app state during the transition, we have to save whichever variables or whichever instance that we like to save during the two method on save instance and on restore instance method. So now we will look into exploring how these methods will help us preserve the important data. So first, without example, I have a code here. I created a counter activity. So in the XML layout of activity counter, where actually we have an counter number, where this is the text view, followed by a button. Where every single time when you press on the button, it will be incrementing by one, which will update the counter number. So in the counter activity, it's just a simple activity where I have created a counter text view and also an increment button where it will increment by one. So here I did not really preserve the value, so we can actually take a look what will happen when you do a screen rotation, what will actually will be the value every time you do a rotation. So I already have the application now created. Now I will actually run back my application. Let's install the new changes into the app. Once the installation has been completed, the app will be launched. So once the app has been launched, we could see that the counter value is equals to 0. When we press on the button, we could see that it will be incremented by 1. Before we do the screen rotation, we should enable the auto configuration for the screen rotation. So once that is enabled, now if you click on the rotation in the emulator, we could see that the counter value, when you change to landscape, is reset to 0. This is because we never saved the counter value, which caused for the reset to happen when the activity is being recreated. Now let's look into how to fix this issue. To handle configuration changes, we should override the onSave instant method to save the current counter value. So let's reset the emulator back to portrait. Let's go back to our counter activity. So the first thing we need to do is we need to create override on save instance where we could save the output, which is the counter, the counter value that we like to keep during the screen rotation. So there's two on save instance. I'm just using the out state. So now I'm basically saving the out state by using a put integer. So it depends on what kind of variable we have declared. I'm using the key counter static that I have declared and assigning the value of the current counter that I'm actually holding. So key counter, counter. So once I have done this, now I'll go back to on create where I will need to read it out if the save instance is not equals to null. So we have to assign it back to the variable. What is the current value that the save instance is actually holding? So in this case, it's the counter value that is actually holding before the screen rotation. So counter is equals to save instance. So I use a put integer. So now I want to retrieve the value. I'm using back a get integer. And I'm calling back to my static variable. What is the static string variable that? So it is key counter. So once I've done this, I go and save and rerun back my application. So once the application comes to the foreground, we could see that now whenever you rotate, we could see that the value number 4 is being retained, regardless you're changing the portrait or you're actually moving back to landscape mode. With this, we have reached to the end of the demo for the Android lifecycle. Next, let's move on to the recap section. Congratulations, you now have a solid understanding of the Android lifecycle. By mastering the lifecycle methods and following best practices, you will be able to create more robust and responsive Android application. Remember, the Android lifecycle is your ally in delivering a seamless user experience. If you found this video helpful, don't forget to give it a thumbs up and subscribe to our channel for more informative content on Android development. Thank you for watching. See you in the next video.